Record. Okay. Just so you know, I am recording this meeting and likely we'll post it on YouTube, right? So I think we'll continue doing that for those people who would like to watch it after the fact. Just as a disclaimer. Now, I don't have anything particularly refined or prepped for today's talk, but I have enough content, I think, that we can have a good discussion from it. But let's get started with the opener. Welcoming people to RocPy. Let me hide. I think I need 2 monitors on this thing. Okay, so I don't know if the 12 people, that's pretty good. Raise a hand if you, so there's a little raise your hand feature wherever that's hiding. Yeah, raise your hand if this is your first time to this meeting, to our group. Let's see if anyone's going to raise a hand or thumbs up or whatever.
Little reactions.
Yeah,
Diane.
I am first time. This is Kannan Kandasamy.
Welcome.
Welcome. Yeah, great.
Thank
Looks
you.
like, yeah.
Yeah, I've only been here once, so it was quite a while ago. So
Cool. Welcome back. Dave, are you connected? Or is you connected as Diane? No? Well, he's probably just going to
This
work.
audio is still connecting. Oh,
Is it?
poof.
Okay. Well, am I coming in nice and clear for everybody?
Yep.
Good.
Yep.
Okay. So let's just get started. So you're here, obviously. You know where you are. You know what you're doing. It's this is RocPy, one and only, the best, top Python user group in the area. Now, hey Josh, can I leave you with the participants list and checking for waiting room? Okay, thanks. I can close that window. I'm missing a font in here. That's why it looks weird. But we have in our group a core set of organizers. Dave, Josh, myself, and poor Emily, who's cut off at the bottom. Well, I haven't seen Emily in a while. I don't know. Is she on here?
I have not seen Emily.
Yeah.
Oh.
Not on tonight, and yeah, she hasn't been here for 6 months.
And well, frankly, it's you guys that make the group, and we're happy to have you here, you fellow Pythonistas. Our mission is to promote, protect, advance Python, and to support and facilitate the growth of a local community of Python programmers. Emphasis on local. We have a variety of ways of contacting us, as usual. Mainly Meetup. I think most people talk to us that way. But the group is only as good as the people who are willing to participate. So we are always looking for people willing to give talks. Having discussions on things that you know little about is as good as being an expert in the thing that you're talking about, because that facilitates discussion and a great sense of community. So whatever you want to talk about, we're happy to have you up at the front of the room to discuss it. Now, last time at RocPy, Josh gave a talk on AWS, and please refresh my memory on the
Lambda.
Lambdas.
Lambda layers for shared libraries across Lambda functions.
Mm-hmm. Yep. And I think we had a few other people talk after that. Tonight, I was just going to give a quick little tour with some sample code of the data model in Python, basically involving the so-called Dunder names or the magic methods, whatever term they tend to use for that. It's not completely comprehensive. There's a lot I'm going to miss and skip, primarily because there's a lot of this that I haven't actually used. But I do have some concrete examples that might be good to show off some cool aspects of what we're doing here. And sorry, I can't hide the noises of motorcycles going by. If you want to contact us for whatever reason, hopefully to offer to give a talk, we have an email address here, org@rocpy.org. We also have a website that has a contact form. If you dare go to our website and look at the crappy, early 2000s style UX design, if that. But we're there. All right, questions, anybody? Probably not. Sounds good. I don't know. Speak up if you have a question. Okay, I think we're good. So I don't have any slides. I'm just going to stick with a Jupyter notebook to talk about some of this stuff and some web pages. Let's get rid of this. Get rid of Slack here. Okay. I have to just start my notebooks. I don't need a tip of the day. I just need you to work. That was weird. It's not what I wanted to do. Actually, can I put this? Yeah, side by side. Python 3 data model. Go to the desktop. Okay, so sorry for all the bouncing around. So here we should see on the left a Jupyter directory. And on the right, I have the web page for the Python 3 data model information. There's always stuff that I'm learning about Python's data model. It seems to be quite rich in many respects. The objects are interesting, and there's a lot of things about it that you should read about that are useful here. Like, we already know objects are Python's abstraction for data. We know how identity works. Every object has identity, a type, and a value. The is operator is used to check identity versus the equal sign, which is meant to check value, value equality, for example. And scrolling through this fairly large page, you see lots of interesting things about, like, I didn't realize about non-implemented. That's a useful object to keep around. Ellipsis is weird, but useful for NumPy, sequences. But we want to get down to we want to start looking at these Dunder names. And there's some of these that are sort of pre-populated and pre-existing based on whatever object you're using. Everything for like the documentation string, the doc strings are in Dunder doc, or function name in the Dunder name, the module name you've just imported, for example. Right? So you can look at some of these attributes already that are pre-populated by Python. So I'm going to call this, let's just call this underscores. There's actually some importance with underscores in Python. And I think it's fitting to talk about underscores first before even getting into the Dunder names. There's some special behaviors with underscores that you may or may not know about. I think some of you may not know about one or two of these items in particular. So we have, let's say, I'll say five different ways underscores have particularly good use in Python. Okay, so let's start with a single leading underscore. If you can't see what I'm typing, or if you have some issues watching, please let me know. So a single leading underscore, for example, underscore var. Now, I've used variations of this pattern here and there. I guess I've been using it wrong. So I don't know if someone has something opposite to say about this, let me know. But this, pardon me, we'll put a bullet there. This is the prefix to hint towards something internal. There's no name mangling as far as, yeah, there shouldn't be any name mangling, but it's a way of, right? Yeah, I know that's double underscores. So there's no name manually. It's just a sort of unofficial pattern to indicate an internal attribute of some sort, right? Function, name, etc. Let's make this a header. So we could create a simple class test, and define what we already know about Dunder and init. Self.foo equals 11, and self.bar underscore bar equals 23. And if I make an instance of it, I could access these things as normal. Nothing special there, but it is still a pattern to let you know that it's something internal. There apparently is, and I didn't quite know this. The leading underscore does affect imports. So if you're doing the wildcard imports from a module, and it's kind of hard to show this here with, can I show this with, yeah, let's try this with Jupyter. I'm gonna make a new file. I think I could do it this way. I'll call it mymodule.py. Okay. And let's define def external func and return 23. And def internal func. There's an underscore in front of that, right? Underscore internal. And return whatever. What we return here is immaterial. It's just the fact that we have two functions defined in this module. One without an underscore prepending its name, and one with an underscore in the front of it. And I should be able to save that. Get this thing out of the way. Preventing wildcard import from a module. Now, if done right, I should still be able to do something like this, right? My module. Okay, hold on. Got to get that cough out. Okay, my module. External func works. Now, I don't know. Internal func still works as well. But where it should prevent you from doing is importing it through a wildcard import, which is bad behavior anyways. You shouldn't be doing the wildcard imports unless you know exactly what you're doing. So from my module, import star, take a look at our namespace. We shouldn't see, and we don't, underscore internal func is not listed in there, right? I don't see it. Do you? I don't.
Nope.
Right? I could test it, of course, right? Thank you, by the way. So it does filter it out when you do a wildcard import. So that's a good thing to know. So
hello, Rich. Can you put your my module on the other tab, or what is your my? Or earlier you put it in another.
Yeah. So what I did here is I didn't actually open up a new notebook, but I used the text editing feature inside Jupyter just to make a new document, which I literally called mymodule.py.
Oh, okay, okay.
Yeah.
So it just returns some that.
Yeah, that's right. Just any Python file you want to make. I always forget about the text editing features of Jupyter.
Oh no, you're fine. Earlier I thought the internal func probably the two add up together, so I was wondering what the module is. Sorry.
Oh, got it. Yeah, sure. Yep.
As another note is this is commonly useful if you're making a package with many files.
Mm-hmm.
You can, in your init, your Dunder init file, you import star from all your sub files, and it will automatically filter out internals.
Absolutely. Yeah. Thanks, Jacob. Yeah, that's absolutely right. Yeah, I've seen that. I've only touched this a little bit with the wildcard stuff like that, using with packages. I usually don't make packages that extensive, but I've seen it in use. Okay, so then what other useful ways can we use underscores? So let's, actually, this should make this a third level. Leading single underscore. And this one, single trailing underscore.
Hey, Rich,
Yes.
do you need to make me a co-host for me to see the waiting room?
Oh my goodness. I thought, oh geez, that's right. I forgot that I can't because you're not in the organization. Sorry, folks. Oh my God. Tons of people just waiting. Yes. Shoot. Where are you, Josh? I lost you. There you are. Okay. Sorry about that. Thank you for reminding me. Completely blanked on that.
Good.
I just brought in a bunch of people, so I think that
I
might be
see that.
Yeah. Those of you just joining, that was my fault. Sorry.
Your fault. I want to take some responsibility for this. All right, I'm going to shut off Diane's because I thought it was my computer again.
Oh, so yeah. Did you connect and then disconnect or something? I thought you were already in.
Diane was in, but then I wasn't.
You sound much better this time.
Oh yeah, you sure do.
I think Dave had his sex changed and he just didn't want to tell us.
Sure did.
All right, so the single trailing underscore. Bring up my notes here.
Okay. There, I'm back to just one computer.
Hey, I was gonna threaten to mute you in a second there. It sounded like you were doing construction.
I was trying.
Yeah.
Actually, Diane's making a lot of racket over there.
Diane.
But is my video coming through?
I don't know.
there
Now your camera's.
Oh, no, your video's not on.
Homemade wild grape wine.
Ooh.
Yum.
Oh, there you are. Yeah, coming in sharp.
Man.
Yeah. So for those of you just joining, I am talking about.
I got a new sippy cup too.
Oh, where'd you find that? My son left it, didn't he?
Yep. It's coming back.
Okay, thank you.
Yeah.
Oh boy. So those of you just joining, I've been having a very in-depth discussion about underscores. Exciting, thorough, sort I guess, about underscores in Python and how they tend to be used. We just finished talking about a single underscore leading an identifier name, which has a convention to indicate internal use, but can also be used to filter with wildcard imports. Now, the next thing I was going to talk about, which is shorter, is a single trailing underscore. And that's typically used when you have a name you really want to use, but it conflicts with something like a keyword, right? You really want to use the word class. You can say class underscore. I've been saying underscore class myself to no ill effect. However, this apparently is the proper way, I guess, to do it. But you trail it with a single underscore. There's nothing really fancy about it. So if I wanted to make a function here, def make object, name and class, right? This won't work because class is a reserved keyword. Now we can fix that up quite simply with def make object, name, class, and we just munge it slightly with an underscore. So, and now it should work. Now it's interesting that I always use pass to indicate a non-implemented function, but I think I was doing a little bit of reading today, and I guess you could do something like return not implemented. That should do the job too. So if you do call it, it actually tells you something's going on. And some silly person thought it'd be cool to do this weird object. There is a literal for ellipsis that is valid, 3 dots,
Okay.
which is, it's a singleton object that's used for denoting interesting slices in NumPy. So regardless, I'm just going to put this here, and I'm going to get interrupted by my son in 10 seconds. I just know it. Here he comes.
Another way to do not implemented is to raise the not implemented error.
Yep. Which you can add a string telling them any extra information if you have any.
So what would happen if we put that 3 dots there and we call the function?
Nothing happens. It's basically equivalent to pass, but
Yeah.
things like type checkers and linters recognize the ellipses, and also certain libraries recognize ellipses as a special value.
Oh, I see. Thank you.
Just 3 ellipses, though, in terms of return, is the exact same as filling your function body with none or a number. Just nothing happens.
Okay, cool.
We're going to go, okay? Say hi to Dave.
Hi, Dave. I know you're here, and I like your shirt.
Oh, thanks.
Yeah, he's very,
I can't go up.
yeah, you can't see. Okay. Say hi.
Hello,
Hi,
honey.
buddy.
And now, goodbye.
Okay.
Yeah,
See how
I
long
was
that
just gonna
lasts.
say, from the previous section, the fact that you can get access to the internal, the ones with the leading underscores, there's no guarantee that the implementations of those leading underscores will remain consistent, whereas the functions without the leading underscores, there's some understanding of consistency maintained.
When you say leading underscores, you're talking about a single or double?
Yeah, the previous section.
Okay. All right. Sorry about the interruption, everybody, but that's the work from home consequence. Okay, so next, this is the one I've used. This is actual name mangling, or whatever you want to call it. Double leading underscore. For example, var. And this here would be, let's make sure we're clear about this. Okay, and this one actually has strong internal features in Python. This actually does stuff. So let's create a basic, very simple class. We need nothing more than just to call it test. Define, well, anything really. In Dunder, it's perfectly fine for this. We want to create a couple of attributes internally. Self.foo is 11. Self._bar is 23. And then self.baz, I'll say it's 42. Whoop. That's double underscore baz. If I make an instance of this, this is, now we can look at the namespace. Let's look at that first. Print, I think there's a way to change how it behaves, but I usually print when I'm printing out things like lists and dictionaries, because Jupyter always tends to do it vertically. So if you can see it, there's a lot of stuff. Jupyter pollutes the namespace with a lot of things. Oh, we don't want to look at that. I'm going to look at T. My fault. That's better. So we're looking at T, and we're going to look at the exposed attributes in T. And we'll notice that foo is accessible, as one would expect. It's just self.foo. The next one is _bar, also accessible by that name. But we don't see double underscore baz, because that triggered a name mangling routine. And it's not very intense. It's actually quite easy to circumvent. So it's really nothing more than a mild deterrent from most people from poking around accidentally and destroying an object. So here, that highlighted part that you should be able to see is underscore test underscore underscore baz. So it's nothing more than prepending the name of the class in front of the intended to be mangled name. And that's it. So now if I wanted to access it, it is pretty straightforward. T dot foo, like normal. T dot underscore bar, not mangled at all. There it is. But T dot underscore baz is not accessible. Test object has no attribute double underscore baz. However, that's for external access. Internal access to that is unfettered. So if I wanted to add something to my class test here, def return, geez. Let's call it just get baz, just for fun. Self dot double underscore baz. I don't have to name mangle it. I can access it, of course. So that's how I do this. And we'll just recreate everything. We know it has no external access to it, but if I call t.getBaz, I now have access to that attribute by way of a method acting as a proxy to the data.
Yeah, Rich, I think that's an attempt at trying to make a private variable.
I think it's the sort of, oh, is that you, Adam? Hi, Adam.
That's Dave.
Yeah, it's a concession, I think, to kind of sort of make people happy. It's like, oh, you want some private namespaces? Here you go. You know, yeah. Make use of it as best as you can. Because the Python data model is very open and promiscuous and all that stuff. You can really do whatever you want. All right, so now the last, is it last or second to last? No, I have one more. This one, which is leading up to our discussion today, and I'm going to save any extensive discussion on this for the second half of this. Double, leading, and trailing underscore better known as Dunder for double. I think it means just for double underscore, right? Which doesn't really say double underscore on both sides, but you know, you get the point. Dunder, like Dunder Mifflin. Now,
Stole my joke.
What's that?
You stole my joke.
I stole your joke. I'm so sorry. Now you can use double, you know, Dunder names anywhere you want. Quite honestly, if I make prefix postfix test, he calls this. Okay, fine. Def Dunder init. Well, there we go. We have one special Dunder name we could use. We use it sort of instinctively. Self.bam. It should be perfectly fine to use. Okay, so I'll say prefix PPT equals prefix postfix test. Did I misspell it? Oh, I got to redefine it. There we go. So PPT. Okay, big deal, right? But I think that the question here is not why this is working, but when we can make it, when we can actually override something to use it for something cool. I can create double underscore names anywhere. That's not a big deal, but using them in the right spots is what we're going to be talking about today to override some of the aspects of the data model built into Python. And the last thing, in terms of underscores, is single underscore. And this one was a relatively new one to me. I didn't really notice this until, gosh, I don't know, a few years ago or something. But you can, for example, have sort of a throwaway placeholder variable. There is a variable holding the result of the last unnamed expression. There it is. underscore, if I evaluate it, shows 42 because that was the last evaluation I did up in cell 33. And it's just a name that's always persistent. I could use it if I don't intend, for example, to have a loop index variable that I want to use for underscore in, range of whatever. Print hello world, or, whatever you want to do. Your intent perhaps is not to use that index variable, and I just want to print hello a million times. Now, however, since it is a variable, you are free to use it as well. Who cares? But it's unnamed, right? Sort of an anonymous variable. It'll be clobbered by the next, I think any result. I'm not sure. I think it's any expression that is not assigned, I believe, gets placed in there. So single underscore is pretty neat. And it's a great way for just holding temporary results. It certainly holds all the results in the interpreter if you're just testing things out. You can always refer to it again after you're done. I think that covers various underscores. The exciting world of underscores. Who's it? I see something popping up in the chat. Dunder Mifflin. That's a good one, Adam. I like that one. I don't know, Dave, was that what you're going to do too? You're just going to say.
I didn't hear. What?
Yeah, Adam posted this. Let's see. Class The Office. I'm just going to.
Oh, yeah.
I'm going to amend it slightly. There you go, Dunder Mifflin. I'm going to remember that one. All right, so any questions about this before we move on? Oh yeah, fantastic. So we'll close this out. Stay on the page. Close. So next, what do we talk about in terms of underscores? Like I said, there's a lot of stuff we can go through. And my hope was to just kind of briefly scroll through what the data model has available. And I have two concrete examples using a fraction class and also a hash table implementation that puts a lot of this stuff into practice. So if you're creating your own abstract data types, which is what our classes are good for, this is a great way to make those data types useful in ways that make them more natural to use with other parts of Python. So let's see what we can do with that. Now you should be seeing over here in the web browser window on the right, as I scroll through, and oh gosh, hold on one second.
Really no.
You gotta be quiet. Not you guys. Well, you can be quiet if you want, but he's gotta be quiet. Okay, so as we scroll through, there's a bunch of stuff that a lot of which I've never touched, but you got things that are built in. Your globals, your Dunder dicts, the defaults, modules, it's all this stuff in here. Instance methods. This is a very long document, certainly worth looking at. Let's see, modules, I have a lot of stuff. In fact, there's probably one place with modules where we also naturally use Dunder names to our benefit. And that's with the namespace check to switch between running a body of code versus just importing it, which we can get to in a minute. Class instances. Yeah, so what we really want to do is look at section 3.3, special name, method names. Now, you can override the, what do we call it? Using Dunder new, override the class creation. What's that? Yeah, class construction, that's the word I'm looking for. Thank you. And you can do stuff in here that I've only used once. I can't think of many reasons to use this. Metaclasses.
Singletons.
Right? Singletons, there's a good one. Yep.
You can. I actually recently implemented a singleton class, which uses new to great effect.
So you just check to see if there's an instance there, and you just return the same thing again, right?
Yep. You can
Yeah.
also even use it for factories. And this is a little more a weird usage, but in theory, you don't need to return the type you're constructing. So I can say just return none or return different types based, oh, sorry, good example. Based on one of the input variables, you can make it a subclass of itself. So if you have a vector with a custom new, it can return, say, a specialized vector 3 if there are 3 input variables, because 3D vectors have extra methods.
That's pretty cool. Okay.
Would you like to start a tutorial next time, Jacob? Sounds interesting.
Jacob does interesting stuff.
I love messing with the far reaches of what Python can do. I've been considering in terms of the data, this exact presentation stuff of re-implementing Python's entire type system and all the built-in property and class method and such in pure Python.
Okay.
So basically,
And-
PyPy.
Cool.
Yeah, basically PyPy style.
Well, that's pretty cool. And that's. I would love to see you do this and talk about it. I think we're in agreement here.
One of the places I've seen this stuff used also is in ORMs.
Oh, okay. Yeah, there's
So-
one place. Yeah, sorry, go ahead, Josh.
Yeah, it was just that, pulling the structure of your object to build the structure of the database tables.
Mm-hmm. Yeah, the one place I've ever used this myself. I don't know if I could show. Did I actually do it here? Maybe not. I swear I used it before. That's how infrequently I've used it. I don't even remember using it. Okay, I'm not going to pretend I've used it because I can't find my example of using it. So anyways, if you do want to override it, Jacob and others have brought up some good examples. Now, Dunder init is the most common one we used because that is your initializer for a newly constructed object that the default or custom Dunder new has returned. And that's your opportunity to set up the state of the object that you just got with whatever you need. Dunder del, never really used. And Dunder repr, this one's a big one. So let me see here. Let's bring up a notebook. And we're going to call this Dunder names. I feel like I should make a Crocodile Dundee joke, but who knows that movie anymore? All right, so Dunder repr, Dunder string. One of the big things about object evaluation in Python and its interactivity is having object evaluate and represent themselves in ways for you to understand what they do. And one of the easier ones I've used one of the examples I've used in the past, especially in my classes, has been, let me see if I can bring it up. I don't need to, I have it right here. I'll go to my class website and go to lectures. Where is it? Down here. Object-oriented design. I'm missing classes. Here we go. I'm going to download my own notebook. Allow. And then I should be able to. Sure. Please let it. All right, so one of the principles of class design, I'm trying to teach my kids how to create a class and the various things you can do in it, and some of the basic. I'm not a software engineer by trade. I'm a computer science guy, which means I'm not a software engineer, and there's a lot of principles of software engineering that I do skip over or do not know. But I do generally know how to write a class. And in Python, this is what I did. This represents a multi-sided die. I'm not going to rewrite it. I don't think there's a point in rewriting it in this case. Let me just stretch this open. But let's review what we have going on here. This is a class that represents multi-sided dice, or specifically one multi-sided die. And referencing sources like Wikipedia, I know what the valid number of sides there are for fair dice, the legal sides for dice. Everything from 1, which is basically like a Mobius strip, to 144. This has changed in the past year or so since I last looked at it, for the number of sides. We're rapidly approaching the sphere at this point, which is actually also a one-sided die. So it's almost full circle. And in this class, which I call MS-DI, I have a class level variable here that is shared by all instances of this class. And I have a bunch of Dunder names that I used. Now, Dunder init we know. And one of the things about Dunder init is you should not return. You don't return any values. Just let it return none. Or don't return it, don't explicitly return at all. And if you have a problem, raise an exception. That's the better way to do it, right? And if I pass muster, and then I can go through here and set some of the state variables I want. So I have checks here to raise exceptions in the case of, say, invalid sides. If I provided, say, something that wasn't an int for the number of sides, or I provided a non-legal side. Dunder repr and Dunder string, you can leave one or both out, they'll default. And in fact, you may recognize what happens when you don't have your own custom Dunder repr or Dunder string defined for a custom object. You see something like that there that I've highlighted for output 10 there. You just get the name of the class and its memory address. Base its data type and location. You can override it, which is what I do. Now, if you override it with Dunder repr, and if you don't have a Dunder string defined, then Dunder repr takes the role of Dunder string as well. But if you have Dunder repr and you want to use it correctly, and they say it here, let's go down. Where was it? Let's hide this navigation. And it moved me again. Thanks a lot. How did it jump that far down? Okay, so called by, oh sweet Jesus, stop doing that. Sorry about that. Every time I readjust it, it goes away. So Dunder repr is actually called by the repr built-in function, believe it or not, to compute the official string representation of an object, which sounds okay, like big deal. But actually what most people may not realize is that the returned string from a Dunder repr should be what they call an unambiguous representation of that object. How was the object created? Dunder repr should return what looks like a valid Python expression that you can then use to recreate the object if you wanted. So I could probably do something as silly as,
Ow,
what are you doing, kid? You okay? Yeah.
That's good.
All right, so we can do something maybe as silly as this. So let's go back here to Dunder names and check out. And, oh, that's silly. It actually took that as a,
Daddy,
yes.
I actually want to take.
Excuse me.
You know, at least he can reason with his son. I can't reason with a 135-pound Great Dane occasionally.
That's just because you're unreasonable, Tom.
Thank you, Dave.
Anybody running a daycare business? Okay, so where did I leave off? So when you do a Dunder repr, and let's try to, gosh, I wish I could import a notebook, but you can't. I can use this guy right here, I suppose. No, let's make something dumb. Let's make something dumb. Dunder reprs happen naturally for certain objects, right? If I say L equals 1, 2, 3, 4, and I evaluate L, that's Dunder repr kicking in. L dot Dunder repr. You get the string 1, 2, 3, 4. Or call the repr function, built-in function, which calls Dunder repr for you to get the same exact thing. It's a great way if you want to print an object with quotes around it without having to go around. If I want to do something fun like this, the list is, and then I can just call repr inside that, string interpolation, and then close that out.
A little fun quirk of lists is that they call repr on their internals, even if you call string on the list.
Say that again?
So if I call stir on the list to convert it to a string,
Yeah.
the list calls repr on each of its internals.
Oh,
not
really?
String.
Okay, yeah, interesting. And in fact, this didn't do what I expected here. Usually I use this to put quotes around my objects without having to worry about it, but
Well, the reason that didn't do, I think, what you wanted it to do is that if you back up a couple lines there,
yeah,
you said L dot repr, put the quote, whereas what you just did there was a repr of L.
mm-hmm.
Change your statement to a print, and rather than doing a repr of L, do an L dot repr, and it may do your
I've
quote.
used the repr like this. In fact, I just used it recently on other
Yeah.
objects. I just think that it's different with, you know what, I get what you're saying, but let me just make sure. Let me just say D equals 42. This is just a minor point, but it's going to bug me if I can get it working. The num int. Son of a gun. I know that works. I was using this recently. Whatever. I usually just because I want quotes around things and I don't want to have to worry
Right.
about escaping or whatever.
Just for the heck of it, amuse me and see if doing it is L dot repr.
I shall not amuse you. Okay. No, same thing.
No. Yeah, Tom, if you look up above, in 3 and in 4 are the two different variations we were just trying. They both have the same output.
Mm-hmm. Okay, well, it's a minor point. Oh, Jacob, go ahead. You're gonna say something?
I think that it's because Jupyter, when you call L, you get the string. Never mind exactly. I think it has to do with how Jupyter is interpreting strings.
It might be. Jupyter does a lot of funky stuff that gets in my way sometimes.
Hmm.
Anyways, continuing on, Dunder string. So my point being, with repr, I can copy this list wholesale and paste it and evaluate it. Right? If I said, is it an eval? Yeah, eval, right? I said eval. Can I do something stupid like this? Let's find out. Repr of L. REPL. Son of a gun. That works. Right? So by calling the Dunder repr on an object and feeding it right back to eval to evaluate that string, I can recreate the object itself. And it happens with other things as well, like range objects, right? If I call range of 10, this is the unambiguous representation of that object I just created. It called Dunder repr underneath when the object was returned anonymously and just presented it. But if I want to say R equals range of 10, same deal, right? Now I have the object in hand. I could copy and paste, call this R2, and remake the object. That's what Dunder repr is supposed to do. It's supposed to give you this unambiguous way of recreating the object. Now, you can't always do that. There are some deep complexities with objects and instantiation construction that you can't just, flippantly just recreate. But silliness here, again, I could just say eval the repr of, R. I'm just, feeding it right back into itself there, and I'm getting an object out of it. So this creates a string fed right back into eval. That's what Dunder repr is doing for us. Dunder string, on the other hand, is free form. Now, you're not bound by any laws here. PEP8, of course, is, or whatever style guide you want to follow, and what Python's documents here say should be followed. But nothing stops you from abusing and misusing the Dunder names any way you want. That's half the fun, after all. Dunder repr, what's that?
Sorry, the default repr for class prints the pointer because that is an unambiguous, unique value, even if it can't be you can't recreate the class object.
That's true.
The
It is
default
unambiguous.
repr is a pointer because it's unambiguous that is the object you just printed.
That is a great point. Yes, very good. Yeah, okay. But I couldn't just recreate the object that way either, though. I can't just.
Nope, you can't just execute it, but it's
Yeah.
kind of the backup. It's still an unambiguous representation which repr wants.
In fact, this is a great point to finish off with. If you notice here in this page here, I highlighted the evaluation D1. There's the name of the class and memory address. And that's what they say right here. If it is not possible to return the unambiguous representation of an object, use that bracketed notation.
Do you see this?
I'm gonna take a break and get whiskey in a minute. But so Dunder string is free form. Now these other things here I haven't really used, so I don't know what bytes and format does. I know what format is and how to use it. Just I never used Dunder format before, nor have I used Dunder bytes. But other things I have used are comparison operator or methods: Dunder LT, LE, EQ, NE, GT, and GE. If you are creating these abstract data types of your own creation and you want to understand, like, can I compare them together? If I create multiple instances of this object foo, can I have every instance of object foo know if one is greater than or equal to the other one? How do we do that? Because the default is really just object identity, I believe, and that's not very helpful. Now let's run through an example of that, putting those methods to work. Let me see what I got here. We can start with a fraction class that I normally start out with my students here. You wanted to write, say you want to write a class that represents a plain old fraction, a numerator and denominator. And we call it simply fraction. Nothing fancy there. No subclassing, nothing like that. And our Dunder init involves self, top and a bottom, excuse me, which we just quickly assign as instance variables of numerator as being top, and self.den for denominator at the bottom. Done. We have a basic fraction class, right? If I said, we'll call this fraction, 3/4, 3, 4, how does that work out for us? It's pretty boring. It's holding our data. We got encapsulation of data going on, but not a whole lot of good representation of it or anything that we can do with it. If I were to create one fraction, let's call this frac1 and frac2. Can I say, is frac1 equal to frac2? Answer is false, because it's doing object identity, and they are two different objects. It doesn't know how to look at the values in this object to tell you that this is 3/4, that both of them are 3/4. So it doesn't know what to do here. So we can continue on with revising this. Let me put put the divider here. Okay, put that here. We'll call this we'll just redefine this as we go along, as we iterate. So okay, a Dunder string, nothing fancy. Actually, it should be a Dunder repper. Let's put a Dunder repper in here. Self return. Well, how did we make this object? Well, we call fraction, and we gave it the numerator and denominator, the top and the bottom, which is I'm going to make this an interpolated string. Put in self dot num, comma, self dot den, and that gets us the unambiguous representation of a fraction in terms of creating it. So now a Dunder string might be something a little more free-form, a little more friendly towards how we expect things to look. str, and I misspelled self twice. Seth. Now in this case, let's return a fraction as we expect fractions to appear, with nothing more than, self.num divided by self.den. Okay, now if I were to recreate this, take a look at frac1. Now we have a good representation of our object, thanks to Dunder repper. But here's the deal. Dunder repper only operates when you do an evaluation. But if you're trying to coerce the object specifically into a string, that's when Dunder string is called. So now if I call print of frac1, I get 3/4. We're getting somewhere, right? This is better. So we've now implemented 3 different Dunder names to do the job. What else can we do? Whew. Well, there's a whole lot we can implement. I think EQ might be a simple one that we can start with. So let's recreate this again. Okay, so now let's add def Dunder EQ. Notice we've put nothing in here that was of our own naming yet. This is just all built-in methods we're overriding. Self and comma other. So the Dunder EQ is a method used to test equality. These abstract objects, you have to describe what it is you're checking for equality. Now, other could be, well, whatever you need. I mean, I can use this to compare a fraction against an integer if I wanted. However, in this case, we're going to allow this to look at another fraction and talk to it. But I'm not going to do any extensive type checking to figure that out. I'm just going to trust that another fraction object is being passed in. So what we can say here is first num. How do I do this? First num equals self.num, get the numerator, times the denominator, and second num times self.den. Okay. And return if those numbers are equal. So just do a little basic fractional math here. And if those values we calculate in that function locally, and we just test them and return the test value. And that's equality testing. Simple as that, at least for this object. So now I should be able to do this. Fraction was created, create 2 of them, confirm frac1 does what we need. And if I say frac1 is equal to frac2, now it's true. They are equal to each other. Whereas if you recall before, they were not. They were false. So now I'm actually checking the values and confirming that they had the same values. Any questions so far? There's a whole bunch of stuff. This is like an hour's worth of work that I'm not going to torture you with, so don't worry. And everything else is basically a variation of this. The scene, if something's greater than or less than, you just change the signs here. You can basically get what you need for the other tests. So if I wanted to implement def dunder LT, self and other, etc., I would do the same thing as I did above, just change the sign of the check that I'm doing right here. The comparison that I'm doing, that is. Okay. Let's see what else. I'm sorry, there's a crying baby in the background. You're probably hearing that in high fidelity. Okay, so now I'm going to stop with the fraction stuff. I think we get the point. I thought hash might be fun. I thought, am I using hash? I'm not, because I'm making my own hash table, which is a lot of work. So maybe I'll just show you a little bits of it here and there. So basically, I can create my own dictionary, my own hash table that has some basic collision detection and all this stuff that is part of a good data structures course. Now, this is probably worth it to just show you rather than rewrite everything here, because there's a lot of stuff. So let me see if I can get this over to my other computer here. Where's this hiding out? Give me a minute, folks. Okay, so now over here, I'm hoping to see my desktop hash table workshop. So this notebook is actually just rough notes from discussion with students. But here, I'm implementing a bunch of Dunder methods. Container length, container size, right? Len, Dunder len. So if I want to get the length of an object, I can I can define a Dunder len and specify that. Dunder bool, Dunder repr, Dunder string. Dunder bool is interesting. We should be familiar with the fact that every object has a truth identity to it, right? If I wanted to say, what is the truth value of 10, we would say that's true. Truth value of 0 is obviously false. But weird, truth value of an empty list, which most of us already know, is false. This is done through Dunder bool. You specify Dunder bool, then you can say that when called, I return what I consider the value of my object to be in terms of Booleanness. And if you want it to be true or false, it's up to you, whatever you want it to be. And that's what we do here. I implement all these things. Now, here's the answer, basically. A class called hash table. And basically, you have a place for storing the keys and the values, and the locations where the key of your dictionary and the value of your dictionary is stored. The position is mirrored between self.slots and self.data. They get stored in the same slots, and it's the hash location is the slot that it gets stored in. So you hash the key, and that says, okay, you get stored in location 15. That's why you can use strings or ints, whatever values you want to use. That in Python, that's what you can do, right? You can use tuples, you can use strings, you can use ints or floats as keys, and they all get hashed into something that allows it to get stored into some normalized way. And that's what's happening here. We're hashing a key and figuring out what index value is this hashing to. And so we keep track of our key and value in two separate lists and some position value here. And here's Dunderlen. If someone asks, how many items do I have in my hash table? I just return self.size. Whoops, that's right up here. I forgot about it. So I am tracking the size, which is not, do I need that? Yes, because the hash table has a predefined length. The way this is designed, there is a limitation in how it's not self-expanding. Oh, you have a good night, Jen-Lee. She left yet. Okay, so Dunder Bool, this is my way of saying, if someone were to ask, is my hash table true or false in some scenario, what would that be? And I just based it on size. I said, if the size of my hash table is 0, it's false. If it's not 0, then it's true. Right? So if it's not empty, it's a truthiness. And that's how you can do things like if some object, you use no comparison whatsoever, but somehow it just manages to make a decision. It's using Dunder Bool underneath. Dunder Repper, Dunder String, you understand what they do. And I just happened to use both. I just didn't care in this case, just mirrored Dunder String to Dunder Repper. Here's contains, Dunder contains. How do I know if something is in my hash table? Or rather, in any object I create, what if I wanted to somehow test? Well, this is using the end keyword. Yeah, the end keyword, right? If something in some scalar, right, is so, like say is X in list L, and it returns true or false. That's what Dunder contains does. Get item. This is the lookup. If you're doing a lookup,
I think that's an immutable. Any immutable.
Oh, what's immutable?
I think if you can test if something is in a collection, right? If it's immutable.
You can do it to mutable objects too.
Oh, you can? Okay. So it's not just scalars.
Yeah, no, because you can do X in Y, and X and Y can be any expression.
I guess I don't know what you thought you were saying. I'm sorry. So if I have some int and I'm checking to see if int is a member of some collection, that collection could be mutable or immutable, right? I could check to see if a tuple has it or if a list has it, right?
What I'm saying is it's not a scalar. You said if you're checking to see if there's a scalar in something, it doesn't have to be a scalar.
Oh, I guess not. I guess not. You're right. Does
Yeah.
it? Does it? Ah, yeah. I guess I've only used it that way, huh? So that's a great point. I got you now. Gotcha. Okay. Well, talk about use cases, huh? Okay, so Dunder get item, set item, and del item. These are the actions that you use when you do lookups in a dictionary, a typical Python dict, or a Python list. When you index, when you delete an item from an index, like del L at 0, you can delete an item from that index position, or to retrieve it or set it, right? These are the methods that implement all this. And there's nothing too fancy about it. You just have some checks in there if you want, and it's just custom to this data structure I wrote. And whatever you need to do with it is up to you. Dunder iter, or iter, turns this into an iterator. Returns self, which is interesting because self is what is using Dunder next, which turns this into an iterator. And this is a complicated looking dealy here, but this allows me to iterate over the items in my dictionary in procedural fashion without any need to do any weird conversion to a list or anything like that. So this is pretty cool right here. Basically how things like range works and so forth, Now we're into my stuff that is not really relevant. This is for the basic usage of the hash table. Okay, and then my testing here is limited, unfortunately. Let me see if I have any. Well, you can see what I've been doing. So you can just do normal let's put this into practice. I keep talking about it. Just use it. Okay. Let's make a hash table with 11 pre-allocated slots, which means self.size here is set to 11. Therefore, the list that I'm using to store everything is 11. So we have a constrained hash table. So I really can't store too much unless we do some specialized collision detection called chaining, for example. So here I have hash table 11, and I could call the methods, my custom methods, to put stuff into this hash table, which is not really cool, right? I mean, who cares, right? This is not really fun. So let's take this out. However, I did add val 1, 2, and 3 with the keys 1, 2, 3. So if I want to say 4, let's see, I should be able to loop over it. If I loop over my hash table now, the iterator in it returns every key, just like a normal dictionary does. And I can loop over and print I, and I see keys 1, 2, 3. I can do assignments. I can say HT. I think this might be designed specifically for integers. So I don't know. Let's try apple equals food. Yeah, didn't like it. I think, yeah, that's right. It's doing some hashing here. So this hash table implementation I have is only usable with keys that are numbers, that are ints. So this is not very helpful for any extensive test, but I can just do something like this. HT, this is where set item, Dunder set item is getting put into use. 42 equals don't panic, and that should work. Okay, and now I can loop over this again, and just to prove to you it's not a list, I now have a non-contiguous range of numbers, 1, 2, 3, 42. And other things, I can say del HT, get rid of 2. And now I've removed key 2 and its value. And also get item, Dunder get item, HT 42 is don't panic. So I basically turned this into a very natural looking object. And we see this all the time with other third-party packages like NumPy or Pandas and all these things where they do all sorts of what we may consider trickery, but actually they're utilizing all the features of the data model very extensively to do stuff like this. Okay, any questions so far? Okay, so that might be it for things that I've actually used to any degree.
I used actually just recently a Dunder for the Dunder dict for serialization.
Oh, interesting. Okay.
So when you use the JSON dump or JSON dump
or dump, yeah.
Yeah. So when if you're serializing an object is not serializable by default, but a dictionary is.
Mm-hmm.
And an object is basically just a dictionary behind the scenes stored in the Dunder dict.
There you go. See? My hash table is not JSON serializable.
Yep. But if you do your instance, if you try to serialize the Dunder dict of your instance, it is.
Interesting. Okay, so if I do this,
just
first
do
off,
ht.dunder dict. Yeah.
Oh, neat. Okay, that's pretty cool. That's pretty
And
cool.
I took it even one step further and used a dictionary comprehension to munge the keys to make them Pascal case.
Oh, look at that. Very nice.
You could probably also do this with YAML.
I use YAML, but I use JSON as well, but yeah, I get the point.
Yeah.
That's pretty cool though. Dunder dict using, that's a neat way to make that happen.
It's dangerous if the object does special stuff behind the scenes, but works a lot for basically any plain old
Yeah.
data object.
Yeah, anything that you're creating, it works great because you can control it.
You know that it's not doing any magic with those values.
Right.
Mhm.
Because dict is really just a kind of map. It's a map
It's a map.
view into the keys behind
Yep.
the scenes.
Yes.
So if that's serialization, is there something parallel for deserialization?
Yes, the opposite of the JSON.dumps is JSON.load and load s.
Although it doesn't produce an object, it still just produces a dict. There's no way that I know of to get it back into your object that you got the dict out of.
Okay, there's no equivalent Dunder thing to go the other way.
No, not that I know of.
Well, you can make an empty instance of the object and then do a dict update on it.
Fair. Yeah, you can rehydrate it essentially.
But you have to do that personally. There's no
That's a
automatic.
software engineering term?
Yeah.
Okay. If you're curious about how to make things to and from JSON, though, you can actually overload the JSON dump thing that you can pass a named parameter that will automatically go to and from dict to your object.
Yes, and which is how I am serializing my object. Essentially, is I have an encoder that just turns around and pulls out the Dunder dict.
Isn't this effectively what pickle and shelve do?
Yep.
Yeah. In fact, so I just did what you guys just described here. I serialized my dictionary using my hash table using Dunder dict, then loaded it back up as an object. Of course, it loads it back as a dictionary, so it's only partially representing my object. And then I did what Jacob suggested and updated Dunder dict right back in, and it seemed to do it. So
nice. Well, there you go.
Yeah. Cool. These are fun tricks, right? There's Dunder slots, which going back to what we talked about with imports, and Jacob mentioned packages and stuff, you can describe exactly what things you want to have imported through a Dunder slots. So it can be assigned a string, iterable, or sequence of strings with variable names used by instances. Oh, sorry, that's a different Dunder slots. That's the one used for in classes. So reserve space for declared variables. I only used that once or twice.
Packages use Dunder all.
Dunder all. Geez, thank you. I had it mixed up. I'm going to say that didn't make sense. Yes, Dunder all is what I meant if you want to control what's being imported from a module. Dunder slots is used with things like, I think, related descriptors or something like that. Shows you you only used that like once, maybe.
When you use Dunder slots, there is no Dunder dict, and behind the scenes, Python only allows things in slots. So whereas normally you can do O dot whatever equals value, and it will just make that if it doesn't exist. If there's a slots, it will error because there is no dict backing the object. It is instead a tightly packed array.
So does it actually? So does it sort of turn into an immutable object in that sense, or no?
Not immutable. It's more think like with Java, where you have to declare every what's the term? Parameter.
Yeah.
Property. That's the term.
Okay.
It's a list of property names, and anything not in those names is an it now raises an error instead of creating it.
Got it. Yeah. Okay.
And
interesting.
It's actually for like memory and speed, because behind the scenes, CPython actually, when there's a slots, generates the object as a tightly packed array rather than a dict.
Mm-hmm.
That's why there's no Dunder dict, because it doesn't have a dict backing.
Okay, that's pretty cool. And which brings up the thought of, can you make your own immutable object?
Sort of, by overriding Dunder gettr.
Yeah.
And setattr.
But that's not foolproof, though.
No, because there's no way to block object.gettr on your thing. But that's because that's a fundamental thing about how Python is done.
Yeah. This kind of goes in with your auditing framework that you talked about a few months ago, right?
Yep, because it can audit object.getAtter.
Yeah. Cool.
I had a question. So I was doing the stream processing, and I'm needing a lot of conditionals, and so I'm trying to limit the number of comparisons that I'm doing. And normally in a dictionary, when you do like a dictionary contains a certain key, that short circuits if it finds it. In Python, you use the in, like value in dictionary, the in clause, the in statement. I haven't found anywhere that states that that actually short circuits. I can only imagine that it does, but I can't find any confirmation that it does.
In does not, quote unquote, okay, so and or will short circuit.
Yep.
But in doesn't I believe does not, because of the fact that in calls contains and can be overloaded to do anything.
Okay. Does contains short circuit?
What exactly do you mean by does contains?
Well, does it, like, if it finds something, does it stop?
If it finds something, does it stop?
Does it stop going through the list and
Yes.
not process the entire list?
Well, that's
Yes.
entirely dependent on how the object was made, right?
Right, but the behind the scenes default implementation on a dictionary, I can only imagine that contains would stop when it
Built-in
finds the first
contains
instance.
is constant time because it's hash based.
Okay.
Because it
That
does
is-
a check
I
on the
would
keys,
hope
and
that it
keys
would be
must be
hash based.
hashable.
Okay, yeah.
Doesn't it
That would make.
evaluate to a true?
What's that?
In.
Uh-huh.
So if it evaluates to a true, then it kicks out, right?
So it's not the logical short circuit, it's the processing short circuit that I was interested in. The processing of, is it looking at the list of keys as a list or as a hash table? And I would hope they would look at it as a hash table.
It's
using
a hash
the
table.
contains. Yeah.
Because dict keys must be hashable, and from what I
Right.
remember, they are.
Got it. Yep. No, that makes sense.
List also short circuits, so its worst case is O of n, but
Right.
because it just checks if it contains it at all, the first one it finds it immediately knows it's true. Whereas false will always have to go through the whole list.
Gotcha. So yeah, anybody else have anything? Any questions? So with we're talking about slots really quick. What does it look like to implement slots?
I personally can't share screen while someone else is. Otherwise, I could actually give a quick example. Okay.
Hey.
Does everyone see my Sublime text?
Yep.
Cool. So.
Gotcha. And that will fail.
Yeah.
Huh. Okay. And so that executes faster. That's more efficient than.
Very slightly. It's
Right.
generally only going to make sense on like when you have hundreds of this object. So like common data objects, it makes sense because of that whole little behind the scenes thing where CPython can optimize it if it has slots because it knows the number of properties, and it knows
What,
that number won't change.
what about in my streaming context? Do you think it would make that much of a difference? Because I'm looping through, and each time through, I am creating new objects. I'm emptying them out at a certain threshold, but do you think it would make much of a difference then?
It might, but you'd have to try, and if you're not already
Yeah.
having issues, it probably wouldn't be that significant.
Yeah.
Because it's the difference in size between a array and a dictionary behind the scenes, basically.
Yeah, it probably wouldn't.
But yeah, so.
Interesting. Cool. Thank you.
If anyone has any other Dunders they want to see, I can show examples for probably most of them.
Yeah.
I can't promise that though.
Yeah. Adam, are you trying to say something? No.
Yeah. Aside from Dunder, the data model page on the wiki on the Python docs has a lot of other interesting notes. Like it talks about some of the built-in types that you don't often see, like the traceback type or the frame type.
Nice. Yeah, I've been using, I made fun use of the slice method for string processing, where I just kept doing a slice taking one, so it basically just kept chopping it in two, getting the next column, if you will. Because like in processing logs, I like the first column is always a date, and then the next column is a type. So I just kind of iterate over it, but it's not always the type. So the slice with passing in a space and comma 1 gives you just the first of that separation, of that separator, first instance of that separator.
Yeah. If there was just a place to drop interesting Python things, I recently made a Python file which deletes everything in built-ins. So you now have nothing but Python syntax and constants, like true and false. And then it rebuilds the entire built-ins module. You can actually, like things like the stir, like stir as a type, you can get that easily because it's just string literal dot class. But things like the function chr are very difficult to get because built-in functions aren't really referenced from anything. So the main trick to it is you getting a reference to sys via some error manipulation, and then from that using that to steal back the ability to import things, because Dunder import is how import's implemented, and that's gone too, so you can't import things to start with. So you have to use some magic to get a hold of sys, and from there you can get a hold of the built-in import lib module, which is always loaded by the Python interpreter at startup, get your ability to import things normally, import the garbage collector, and tell it, give me all garbage collected objects, and pull out all the ones you want and put them back in built-ins.
So you're just basically undeleting everything.
Yep. Because, fun fact, I tried. The garbage collector, as far as I can tell, will never actually clean up built-in functions until the interpreter shuts down. Because I tried getting rid of all references to them, and they still would never clean up.
It's probably a safety mechanism, yeah.
Yeah.
Interesting.
I like doing weird things with Python for no other reason than to see if it's possible.
No,
You can
absolutely.
be garbage collecting garbage collector. Recursive garbage collection.
The garbage collector can collect everything. Does that include the garbage collector module? Why, sorta.
Yeah, I like to see how like you can play around with the different built-in functionality to make it more efficient than you think it can act. Then you can typically get it. So like using the split and slices as opposed to looping through strings to process the strings.
Mhm.
Like what I really want, I always struggle with pulling data out of strings, whether or not it makes sense to use a regular expression for readability's sake. Whether like sometimes regular expressions make it fairly straightforward, and sometimes they make it very much not.
Mhm.
I tend to try to avoid them because they can very easily get into that not side of things.
The one thing I heard for regular expressions is you can define them as write once.
Uh-huh.
You create them and then you hope they work forever.
Yep. Yeah, I find trying to do split is usually fairly efficient and much more readable.
Yeah.
So I have an off-topic question.
What's up?
What state is Adam in?
I don't know.
He's on mute. We'll never know.
He's probably in New York State, but he's probably down in Long Island.
That's entirely possible. So where are you at, Adam?
Right now I'm in my daughter's room. She always needs something when there's a Zoom meeting going on, but I'm
Of course. But where are you guys where's home base now?
still in Rochester.
You are still in Rochester?
And they're thinking about really, I gotta go through. They're thinking about really extending telecommute permission, I guess, because of this mess.
Yep.
That lab is like right in the epicenter of everything right now. It's insane. So
yeah, that makes things a little challenging.
Yeah.
So you've been social distanced to upstate New York.
That's right. I'm the farthest. One guy went home to Chicago, and I'm here, and everybody else is just locked in their apartments in New York City. And
well, isn't that the follow-up to the joke from a few months ago? Was it New York Post had that journalist, and I use that term loosely, who called Rochester a dark and gloomy place or something like that. And then I believe they just had an updated headline like a few weeks ago saying, Rochester, is it a new destination to move to? No. So, who knows?
Well, it certainly got us a lot of headlines.
Yeah.
You know, there is actually one Dunder I know of which isn't documented on the data model.
Oh, which one's that?
Dunder subclasses.
Interesting.
Not subclass check, which is, but just subclasses, which is a method that can be called to get all subclasses of a type as a list.
Well, that's handy. Yeah.
And
so that the terminology always makes me stop and think for a little bit. Subclasses are things that have inherited from me.
Yes.
That I am their parent, essentially. Okay.
Yes.
Josh, did you end the screen share or did I?
I did.
Okay.
I gave an example of slots.
Oh, it's fine. I walked away and it was rude of me, so I apologize. But
thank you for making me co-host.
You're welcome. You guys are trapped.
Can I go back to Rochester for a minute?
What's up?
You guys know Jim Gaffigan?
Yes. Yeah.
He was rather smitten with the garbage plate last time he was here, so he's
Nice.
talked about it on several occasions.
How can you not be?
It's a novel concoction.
It is. It's delicious now.
Concoction is an accurate description.
Mm-hmm. Josh, did you want to talk about your thing or no?
Well, I've kind of talked about little bits of it, but I'll give everybody an overview. What I'm hoping to put together a talk on, and probably won't be too hard for next month, is the AWS Kinesis Consumer Library. The core of it is a Java application that actually has multi-language daemon, which means it has a series of different languages that it will communicate with, and it communicates over standard in, standard out. So as with the Java application, it's less of a library and more of a execution context. So it starts up the Java application and then executes your code within it, and communicate as another within it in loose terms, but it executes your code and communicates with it via standard in, standard out.
Almost
And
more like a debugger.
yeah, but which means it's a little bit difficult for you to debug. So you have to import a debugging library and only load it if you have what I did was I only load it if there is a debug environment variable. And so then you can connect, it opens up a little server that you can connect to a port on your local machine, or in my case, in a Docker container. But it works great. Once you have it, you just have to start up the application, and then once it hits that, you can go in and say, start my debugger, and you can put breakpoints. So your little application runs through and is fed the stream of records off the Kinesis data stream, which is basically a queue that is pushed to you instead of you pulling, and is designed to be very high efficiency. So I'm taking things and aggregating log entries that have multiple entries, and they want to see them as single, and extract the kind of compose a data object out of them. And it's pretty cool.
Yeah. Well, I look forward to it.
Yeah, I've been having fun with it. I also have I created a Kinesis producer app to mimic the stream coming out of the log generator, so I can just replay as much as I like. So it all works really slick.
Pretty cool.
And it was also one of my first serious endeavors into containerization. So always fun.
And by containerization, you mean like Docker?
Docker. Docker.
Have you guys used anything that's not Docker, like straight up containers?
I have not.
Okay.
I know that there was precursors to Docker, but I have not yet seen any indication that anyone is using anything but Docker.
Well, there's the underlying containerization framework that Docker is based on, and
so on Linux,
yeah,
this is true. I think what has gained Docker so much foothold is that it goes beyond just Linux.
Nonsense. There's nothing else but Linux.
I know there's nothing else out
But the
there.
tricky thing is though, does Windows have a native containerization framework, or is it actually?
It uses hypervisor behind the scenes.
Yeah, the same thing with the Mac. It uses a hypervisor to
Mhm.
boot up a Linux instance.
Yep.
Hmm.
Although I don't know so Windows with this in the next month or so, I believe, is going to be releasing an update that will release an entire Linux kernel within Windows. The Windows subsystem for Linux, they are releasing a Linux kernel in Windows.
Will my ls finally work when I type it at the command prompt?
No.
Not from the command prompt, but you have
Just
a
map it to
WSL
DIR.
prompt.
Yeah,
I've
Windows
actually been using Bash on Windows.
yeah, the Windows subsystem for Linux is really cool, and the 2.0 version is they
it's
just
like-
are flat out just embedding Linux
Yeah.
and
Yeah.
running it as a native container.
I don't know if you have to explicitly install it, but if you go to command prompt and just type in WSL, I believe it should bring up a Bash terminal.
Yeah.
I've never heard of so many Windows people so excited about Linux.
Well, it's because the two worlds never played nicely together, and now they do.
Well, the Linux world played well with the Windows as best they could, but I don't
Right,
think
but Windows all said no.
Yeah.
You know what though?
There's actually been there was an article. I didn't actually read the article, but the headline was Microsoft admits that they were wrong about open source.
Yeah, and then they bought GitHub.
Oh, yeah, but they've been doing great things with it, and so they're
still
embracing.
But they screwed up Skype. I'll never forget.
Skype was screwed up before they bought it. I'm not saying they're perfect, but they have. I think that they've finally seen the light when it comes to open source.
And who
They
are
open
you
sourced all their
calling?
development.
And who are you calling a Windows person anyway?
I'm a casual Windows person, mainly for.
My work is still my work PC is Windows. We do .NET development mainly. Although the project that I'm working on with the Kinesis data stream, that's just a portion of an entire project that is totally Python.
The client uses Windows.
Oh.
Sorry. The client uses Windows. I'm stuck.
Yep.
I use Windows as a gateway to Linux at work.
Right. No one mentioned installing OpenSSH under Windows now officially.
Oh yes, you can install OpenSSH.
I did that the other week, and that was pretty wild to just get a command prompt showing up remotely.
It's funny that something so simple has taken so long to get there.
Yeah.
I use CMake to build all of my Linux projects via Visual Studio. So
Nice.
yeah.
I had to use Make in the Docker container. You guys actually helped, Rich, you helped me with it last time. I ended up having to use that because for the Docker container that the Kinesis consumer application runs on, I had to use a Java-based container because I couldn't, for the life of me, get Java to install onto the Python-based container. So I installed Python on the Java-based container.
I'm a big fan of CMake. It's really nice.
Well, CMake makes it so that you can, no pun intended, you can use Visual Studio as your IDE for anything and everything.
Well, CMake's great on its own.
Yeah.
Because I use it for a lot of the C++ projects I work on or help out with because a lot of the developers are on different systems. So rather than having to try to figure out projects for everyone individually, you just say CMake, make me an X project, and it will do.
Oh, so it has nice scaffolding.
CMake is basically so you have Make, you have Visual
Mhm.
Studio projects, you have code
Mhm.
blocks, you have all these projects. You have, what's it called? I forget, but you have a Ninja. CMake is the level above where it is an abstract project framework where you say,
Right.
I want a project that compiles these files into this target and has these properties, and then CMake
Right.
generates any project type.
Gotcha. Oh, that's cool. I like it.
Yeah, it's really handy.
So on the Windows Linux, I never understood. Is it Windows is not yet written on top of Linux?
No,
No.
it basically just another application running on the OS, for lack of a better way of framing it.
They're probably just shimming the Linux syscalls to Linux.
Well, that's what the version 1 of the WSL was
Mhm.
very much a shim, but they went even deeper with WSL2.
Yeah. Rather than a shim now, it's more like a lightweight container where you have the
Yeah.
whole kernel
They really
compiled
did.
into native code, but
Is it segmented memory wise? I mean, they're not.
I'm not completely sure on the.
So I don't know how segmented it is. I did see that they limited it to it can't take more than 80% of the system memory.
Oh. Okay.
But yeah, it's interesting. And though I
Like a
still,
virtualization.
what's that?
Sounds very much like a virtualization.
Yeah, it is, but it's lower level than most virtualizations that you think of. Like they really went right down in as deep as they could, as opposed to traversing the existing paths. The one thing that I'm curious is if I'll be able to run Docker in WSL, because that's the one thing I can't do, and it still behaves a little bit differently because of the Windows file system versus Linux file system. You lose the file execution flags. So you have to run chmod to reapply your execution flags in your Docker file if you build the container on Windows. So
Yeah. There's a big thing where they specifically tell you to not look at the WSL files from the Windows Explorer unless you use the new, they actually added it so you can mount it, but if it's natively stored somewhere in your file system, but don't mess with it with Explorer because it'll just flat out destroy all your file flags.
Yep.
Because they use some magic to convince Linux that file flags exist on a low-level file system which doesn't support them.
Yep. Yeah. Don't do that.
Similarly, symlinks are weird.
Yeah. Well, yeah, Windows has its own style symlinks, which I've used, but are very awkward to actually use. Not like real symlinks.
What do they call them? Junctions or something weird like that?
I think they're actually called symbolic links.
Okay. Okay.
Are they actually hard links?
No,
No.
well, yes, actually, yes, they are, and that's why I used it, because it like Windows has a concept of a shortcut, but it's really like the file system doesn't really acknowledge it. It's a very high level concept, so I wanted a shortcut into something very deep that I could use like a folder, like a symlink. And it is possible. I have done it. but it was very awkward to set up. Okay, guys. That was really great.
Yeah, thank you everyone for coming.
Yes.
Do we
So
do
are we
it
going to get a beer next week?
I'm going now. I
Absolutely.
don't know about you.
Right out of my basement. I just actually stocked up.
So Tom,
Yes,
you
sir.
turned all white. I don't know what's going on, buddy.
I know. I got to get out in the sun more.
Looks like Obi-Wan Kenobi from Star Wars there, just sort of like a Force ghost.
Our only hope.
Okay.
All right, guys.
Good
See
night.
you next week. Or, yeah, well, I'll see you next Tuesday.
Hey, everyone.
All right.
Hey, Jacob. Thanks for coming.
Yeah, I meant to come to the other ones, but I completely forgot on the day of.
Oh, it's fine. You're here now.
Yeah.
Yeah.
So are you actually doing a meeting next week, a planning meeting?
Did we do one? Yeah, we
We
yeah.
did one.
We
Yeah,
did one
yeah.
last month, didn't we?
Yeah, we shared beers together.
But it's
Virtually.
You're doing one next week though, or
Yeah, the next Tuesday.
Next
Oh,
Tuesday.
Same time.
BYOB.
What's that?
BYOB.
Yep, that's right.
Yep. Social distancing is a must.
Same bat time, same bat hour.
Wow, that's an old reference for a young kid.
Actually, it's 6:30. I was gonna say, Jacob, you're not that old, so.
BYOVP, right? Volcano plate?
Yes.
EGIF.
That too. Yes.
Okay. Well then, I will talk to all you guys on Tuesday.
Yep.
All right. Sounds
Adam,
good.
you have no excuse now. It's a virtual travel.
I'll be here every week now. It's great.
And you too, Dave. Okay.
All right.
All right.
See ya.
I'm good to talk to you. Everyone else, Arthur, Jacob, Mitch, Kanan. I don't get a chance to talk to you at all, but thank you for joining.
All right. Thank you. Good
Okay.
night.
Yeah. See you later.
All right.
Yeah.
Bye-bye.